Hi everyone, welcome to AIMS India's online classes. This is Purnima. Today we are going to learn about matter in chemistry class. Okay, what is matter? In our daily life we are observing so many things. As here, if we observe, it is a solid, liquids, gases, and these solids, liquids, gases, everyone we know very well, right? What about these condensates, plasmas, everything, every basic knowledge about the chemistry we are going to learn in this course. Okay, let us start with the introduction of the matter. See, what is matter? The whole universe is composed of matter and energy. As we are learning the chemistry, this chemistry is the branch of science. In science, we have a different branches. See, physics is also the branch of science, biology, zoology, like we have a different branches. In that, chemistry is one of the branch. What this chemistry deals with? This chemistry deals with the study of composition, structure, and properties of matter and the various changes it undergoes. What this matter undergoes the various changes. We are going to study about these. What are the changes occurs in the matter? Everything we are going to study now, learn now. Okay. See, matter. Matter is anything that has mass and occupies space and can be perceived by our senses. See, air is the matter like we can consider because that air we can feel, we can sense that air. See the chair. If you are sitting in one room. In that, if you can observe some of the objects which are placed in your room, the chair, the sofa set, and everything that which you can feel, which you can sense, all those we can consider as a matter. Here are some of the examples are given. See the glass and the ice cubes, and this is the chocobar, and this hot pan, and this one is the volcano, and this air. Everything is a matter, and the particular specification is which has mass and which occupies space we can consider as a matter. See, as we look at our surroundings, we see a large variety of things with different shapes and sizes and textures. In this figure, we can observe the milk packet, and here we can observe the Coke bottle and balloons, pear fruit. These are the books, and this is hot air balloon, and this is the pen. All those are matter only with different shapes, with different sizes. All these we can consider as a matter because they have a mass and they occupies some space. So we can consider all these examples as the matter in this universe. That is what here they are explaining. Everything in this universe is made up of a material which scientists have named matter. Everything in this universe made up of with some material, that one we can consider as a matter. But which type of material it is making is very important. See, the air we breathe is also a matter, and the food we are eating, this is also a matter, and some plants and also some toys, everything, stones, stars, plants and animals, everything which has a mass and which occupies the space which we can sense. So all those we can consider as a examples of matter and as the matter. What are the characteristics of matter? Let us see. The characteristics of matter is, first one, matter is made up of tiny particles called molecules. See, tiny particles means with small particles. The whole matter is made up of small particles. Those are called as molecules. Again, these molecules are made up of small particles called atoms. Molecules only small one. Again, these molecules is made up of with some more small particles. Those are called as atoms. See, these molecules, as they are very tiny particles, we are unable to see with our naked eye. That is also one of the characteristics of the matter. That one, that matter made up of molecules, those molecules are very small. Those we cannot see with our naked eye. And as this matter consists of molecules, those molecules are under constant vibration, All material bodies have mass, hence have weight. That mass with gravitational force we consider as a weight. So all the material bodies which have a mass, that is called as the weight. All materials occupy space. So from these two characteristics, all the material bodies having some mass, all materials occupy some space. So we can call this is as a matter. All the materials, everything, that material we consider as a matter, but this matter exists in different states. Okay, that different states, how we can understand means the arrangement of the molecules. According to the arrangement of the molecules, the matter is in different states. Let us see how those molecules are arranged. Based on those arrangement only, we are going to classify the matter. So our next topic is classification of matter. How we can classify the matter? Let us see. As there are so many kinds of matter, because as there are so many different materials are existing, so different kinds of matter is also existing. A scientific study of matter becomes easier if we classify matter based on some characteristics. Mainly this classification based on two factors. The first one is the physical classification and the second one is chemical classification. Let us see the classification of matters flowchart. This is the classification of matters flowchart. First, this classification of matter is two types. First one is physical classification and second one is chemical classification. Again, this physical classification has total 5 types of classifications. First one is solids, liquids, gases, plasma and Bose condensation state. Let's come to the chemical classification of matter. These chemical classification have pure substances and mixtures. Again, these pure substances are classifying into two types. First one is called elements and second one is called compounds. Come to the mixtures. Again, these mixtures are classifying into two types. First one is homogeneous mixture and heterogeneous mixture. Again, we'll study what is pure substance, what is mixtures, what is element, compound, what is homogeneous mixture and what is heterogeneous mixture. About every each individual definition we will study. Okay, again these elements are going to classify as metals, non-metals, metalloids and noble gases. So in this physical, so this is about the flow chart of the classification of matter, mainly the physical classification and chemical classification. Let us see the physical classification of matter. As we discussed in the previous, the physical classification of matter. See, matter is composed of extremely small particles. Yes, molecules only small. Again, that molecules are made up of tiny particles called atoms. Already we studied about that, right? So based on arrangement of these tiny particles, matter is mainly divided into three types. All we know what are those three types. Those are solids, liquids and gases. This is the different forms of gas, like we can consider water, different forms of water. See, water, this is the ice cube, water only, but it is in solid state. What is solid state means? See, in a fridge they'll give the molds, right? Some water you pour on the mold and if you keep in the deep freeze, the same water is converting into the ice cube, like this one we'll observe daily in our daily life, right? So that ice cube, water only converted as the ice cube, that is called solid form of water. Okay, see, daily we are drinking the water, that is the liquid form of the water. If we boil the water, it starts evaporating, that is called gaseous form of water. So solid form of water, liquid form of water, gaseous form of water. Like that only, we have a different arrangement of the particles based on that solids, liquids and gases, like we can classify the matter. That is that to physical classification of matter. Let us see. About the solids, first one, what is meant by solids? See, in solids the molecules are closely packed up, because the molecules are closely packed up means their positions are almost fixed. That's why solids retain their shape. See, the small circles, we can this one, if you consider as a molecule, all these molecules are arranged very near to each other, right? So they have a fixed volume. If one solid is the ice cube, you, as you know, if you keep one in one place ice cube, that ice cube will be there only. If you take a chair, chair is also a solid form. If you keep the chair, unless and until apply some external force, the chair will be there only. The chair cannot move by that self, right? So anything, any solid that will have a fixed volume. Pen, if you are taking, it has a fixed volume, it has a fixed shape. Ice cube, it has a fixed shape. Anything, if you take any solids, they'll have their fixed shapes and they have fixed volumes. Those are said to be solids. And in these solids, the force of attraction between these molecules, if you observe, see, this is one molecule and this is one molecule. Both are placed and they are arranged in a particular order. The order is fixed, right? They are arranged in a particular order. So the space between these molecules is very less and the forces of attraction between these molecules is very high. Force of attraction is greater and the distance between the molecules is very less. So those are said to be solids. Okay, see examples. Ice we can take. Brick. Brick is also a solid. Piece of chalk is a solid. A metallic pot. Everything which has a fixed shape and fixed volume, that we can consider as a solid. Okay. And generally solids cannot be compressed. We cannot press. Chair is there. Can we press the chair? Brick. If we press, can we press the brick and can we change the shape of the brick? No. Generally solids cannot be compressed. And solids does not flow. If you keep the chair in one place until and unless applying some force on them, otherwise some other persons come and move that chair, unless the chair will be in that place only, so it does not flow. And solids expand very little on being heated. So the expansion on heating is also very less because the molecules are tightly packed in the solids. Already we saw that picture in the solids. Solids have very less interparticle spaces because the distance between the particles is very less. That's why the expansion is also very less and very high interparticle attraction. As the particles are very nearer to each other, they have a very high force of attraction between them and very less space between the particles we can observe. These are the general properties of the solids. Okay, let us see the next states of matter is liquids. What is meant by a liquid? See, in liquids, the molecules are not packed closely. If we observe the solids, the molecules or particles are arranged side by side. But in case of liquids, the molecules are not having a particular shape. They will not arrange side by side. There is a gap between the particles or molecules present in the liquids. That is what, see, liquids change their shape easily but not their volume on their own. So it doesn't have a fixed shape but it has a fixed volume. If you take one glass of water, the water will take the shape of the glass. If you take water in water bottle, the water takes the shape of that water bottle. So the liquids takes the shape of the container but they will not change the volume. The volume will be their own. Okay, but they will take the shape of the container because the intermolecular space, that is the distance between, this is one molecule and this is one molecule, the space between these molecules is, when compared with the solids, it is high. Solids has very less space. When compared with solids, liquids have a more space between the particles. and the forces of attraction between the molecules are also weaker when compared with the solids has high force of attraction, whereas come to the liquids, the forces of attraction between the particles is very less. Okay, and that is why a liquid does not possess definite shape and takes the shapes of the container, we can say. If you take in a glass, if you take in tumbler, if you take in pot, if you take in one steel container, whatever you are taking, it takes the shape of that container. Liquids generally takes the shape of the container. If you take a honey is also a liquid, but the density is more when compared with the water, but that takes the shape of that bottle, honey, right? Like that only, they won't have a fixed shape, but they'll take the shape of the container. Okay, examples: water, milk, alcohol, tea. If you pour in the glass, that takes the shape of the glass. If you pour in the cup, that will take the shape of the teacup like. So what are the general properties of liquids? This is the first one. A liquid has no fixed shape. Yes, it takes the shape of the container. And a liquid can be compressed only to a small extent. Yes, because why it is compressible? Because there is a space between the molecules in the liquids. Because of that reason, we can compress the liquids. Next, liquids can flow. Yes, liquids can flow. If you take one glass of water and pour on the floor, that will flow to some extent only, not too much. That depends on the how much amount you are taking. If you take a glass of water, small glass of water, it flows into some extent. If you take a bucket of water, it will take more flow. That depends on the quantity of water, but liquids can flow. Okay, and next, liquids expands or contracts more than a solid. Yes, why? What is the reason? Liquids can expand because they have a spaces between the particles. They can contract because they have a spaces between the particles more than a solids does not have a space between the molecules, but whereas come to liquids, they have a space between the molecules and particles. Because of that reason, liquid can expand and contract more than a solid. Next, liquids have more interparticle spaces and less interparticle attraction compared to solids. Yes, that is what we explained now. Okay, now come to the next one, gases. See, what is meant by a gas? In gases, the molecules are a greater distance from one another. See, solids have a fixed shape. The force of attraction and the spaces between the molecules is very less. But whereas come to the liquids, when compared with the solids, the distance between the molecules is more. Whereas come to the gases, the distance between the molecules is more than the liquids. Lot of distance between the molecules. They are free to move. They have a gap. They can move. If you take a scent bottle, if you spray that scent bottle, that smell spreads throughout the room. If a gas leakage is happen, if cylinder is there while cooking, that cooking gas, if you leak that gas, then that smell flows throughout the room and it comes outside also. So these gases are free to move. Neither a fixed shape nor a fixed volume. They don't have a fixed shape and fixed volume. In a gas, the molecules moves very fast because the space between the each molecule is very high. Because of that reason, they can move very fast. The interacting force between the molecules is very weak and molecule enjoy full freedom of movement, because when compared with the solids and liquids, molecules in the gases are free to move. Hence, a gas has neither definite volume nor a definite shape. Once if you recollect the before points, solids have definite shape, definite volume. Whereas come to the liquids, liquids does not have a definite shape, but it has a definite volume. Whereas come to the gases, gases has neither a definite volume nor a definite shape. Examples: oxygen. Yes, they will be throughout the atmosphere. Carbon dioxide, right? Carbon dioxide also a gas. These are examples of gases like we can consider. Now come to the general properties of gases. What are general properties of gases? The first one is a gas has neither a fixed volume nor a fixed shape. It assumes the volume and shape of the container. See, if we observe in our kitchen, a cooking gas means cylinder. The shape of that gas will be that cylinder shape, and that 15 kg gas they have compressed into that cylinder. So the volume and shape of the container will be whatever we are taking, that is not fixed. Gases can be compressed more than solids and liquids. Solids can compress a little bit. Liquids can compress more than solids. Gases can be compressed to a large extent than the solids and liquids, because the intermolecular, because gas expands a greater extent on being heated. What is the reason? Gases freely mix with one another. Why? What is the reason? The whole reason for all these points is the interparticle space is negligible. Means there is a distance between the molecules is more, very large interparticle spaces, and negligible interparticle attractions and space, those are high. The spaces means distance between the molecules is high, so they can be expand and they can be compressible, all the gases. Okay, now the fourth state of matter. Now we have finished three states of matter. First one is solids, second one is liquids, third one is the gases. Now the next one is plasma state. This is the fourth state of matter. What is meant by plasma state first? See, plasma is the fourth state of matter and it is similar to the gaseous state only. But what is the difference? The plasma is made by heating a gas. When you are heating the gas, that state is said to be plasma state, because when you are heating, the molecules or atoms present in the gas, they lose the electrons and they form some ions, but those electrons and ions both are present in that state. That is said to be plasma state. Both ions and electrons to coexist means, if you take one container, in that gas is there, you are heating. In that container, when you start heating, the whatever the gas is present, that gas starts lose the electrons and forms the ions. When electrons are losing, immediately those atoms are converted into the ions like. So both electrons and ions are coexisting in one place. That is nothing but called a plasma state. See here, sun is the near sun and stars we can take as an example for the plasma state, because sun is very hot, isn't it? Yet nearby the sun, both the electrons and ions will be coexist. That's why we can take the sun and stars consider as a plasma state. See here, the plasma is produced in sun and stars because of very high temperature. Sun, very high temperature there, so they glow because they are losing the electrons and they are forming the ions. Because the both are coexisting, that state is called plasma state. The best example for plasma state is sun and stars at that state. Okay, see, on earth plasma is naturally occurring in flames. When you are heating, when the flame lightening and northern and southern lights, in these regions we can observe the plasma state. When it is lightning, even here also very high temperature will be there, because of that on the earth. Now one example at sun and stars, and also on the earth, we can observe in these places the plasma state. Okay, now come to the next state, Bose-Einstein condensate state or BEC. This is called fifth state of matter. What is the name of this one? Bose-Einstein means two scientists. Who are the? Albert Einstein and Satyendranath Bose. These two scientists have predicted this Bose-Einstein condensate state in 1924, which is referred as the fifth state of matter. What exactly this Bose-Einstein condensate state? Let us see. It is a gaseous superfluid phase formed by atoms cooled to temperatures very near to absolute zero. Actually, absolute zero temperature means 0 Kelvin or minus 273 degrees Celsius, means we are cooling very much. Minus 273 degrees cooling is means very cooling. That is called absolute zero. At that cooling, plasma state is at very high temperature and this Bose-Einstein condensate is at very low temperatures. See, this BEC is a state of matter of a dilute gas of bosons cooled to temperatures very close to absolute zero. This absolute zero temperature means either 0 Kelvin or minus 273. Minus 3, minus 2 only we cannot be. We can't be at minus 3 degrees Celsius, minus 2. So it is minus 273 means very low temperature or 0 kelvins. Even Kelvin also is one of the unit of temperature. This is called absolute zero. At this absolute state zero, we can observe this Bose-Einstein condensate state. Under such conditions, a large fraction of the atoms collapse into lowest quantum state producing a superfluid. Gas is actually it is a gas, but you are decreasing the temperature, so it obviously convert into the fluid like, isn't it? Oh, liquid is there. If you decrease the temperature you are keeping in the fridge, that liquid is converting into the solid like that only. Gas, you are decreasing the temperature to minus 273, then it convert into a superfluid. That is the lowest quantum state producing a superfluid, that is called Bose-Einstein condensate state. So students, today we have discussed about the 5 states of matter: solid state, liquid state, gaseous state, plasma state and Bose-Einstein condensate state. Okay students, thank you for watching our video and please subscribe to this YouTube channel Aims Today. Okay, thank you so much.